Good morning, sir. It's 7 a.m. It's time to begin work on your Valorant project.
So here we are, back to building in public here on YouTube. Admittedly, not everything you see is captured by a camera, but what I build is absolutely real. Let's get back to work, shall we? I've been running an AI company for a few years now. Every Thursday, we close our code, order pizza, and we open up a video game. We always play the same game. That game is Valorant.
Look at this shit! Let's rush the bonfire!
We are going to build a Valorant coach that can help me, but also everyone else, level up. Valorant is actually quite a complex game. So you've got different characters, different abilities, different maps. So I want to start there. I want to start with figuring out where you are and on what map.
Oh, look, it messed up for a little bit, and then it readjusted. Look at that scale drift, bros. Scale drift and monocular slam.
If we don't understand where you are on the map, we can't give you advice. We can't figure out how best to play your character. So we have to be able to do that by just looking at the raw pixel values of the game. No API, no help. We have to understand like you do, like the player does, by looking at the screen. I don't think we have to know your exact pixel position. I think we can just use a grid reference.
Riddles of the grid.
So what I want to do is I want to overlay a grid over the whole thing. And then I want to train a model to just know Valorant. So I'm going to get Danny to label a fuck ton of Valorant data. And we're going to feed it into a neural network. Usually you move around a map in a certain way. You rarely teleport across or anything like that. I think I want to build a sequence transformer. It will look at the grid references you just were to figure out like a better idea of where you probably are now. So using the sequence transformer in this way should hopefully yield like really good results. Danny has labeled the entire data set. It's like the entire map, every single map, going around, clicking where he is, trying to tell the computer, just trying to really get a better understanding of every single map. If this works, we might be able to eventually do it without training on the map. So that's the goal, but right now I just want to run an experiment and see can we learn where you are on the map by doing supervised learning. And then maybe we can go to unsupervised learning if this goes well. Okay, it's the end of the day. I just kicked off the first training run. I'm not sure whether it's gonna work. I've set it to only look at half a second of footage for the sequence, so the context length might be a bit short. Let's just stop here for a second. If you made it this far, thank you. I've been making videos for millions of people over on TikTok for a few years now, and I really want YouTube to be a more wholesome, technical space. So if that sounds good to you, hit the subscribe button, and I'll see you in the next one. Okay, so I just got in. It is Wednesday and the run has finished, the first run. Let's see what this bad boy's learned. While the model was training yesterday, I built this little test rig. In the left corner, it shows you the position that we're predicting and also where we think you're looking. And then in the bottom right corner, there's a version of the map, and the red dot is the location and the blue dot is where you're looking.
and it's kind of getting it. It's roughly the region of the map where the player is. Now this is a piece of footage with no abilities being used, no other characters, just literally a map walk around. And it's kind of getting the region correct, but it's not to the quality where you could actually use this in production. Nowhere near. Like, we need a new method. So I went through the entire dataset with like a fine-tooth comb. It is nowhere near big enough. When you take the dataset and you turn it into sequences of movements across the map, you actually only get a few thousand sequences. You actually get less than 100 validation samples as well because of the training validation split. It might not actually be learning to do map positioning at all. It might be just predicting values based on like colors or something. I have a hunch it's not actually learning the task that I want it to learn. I need tens of thousands of sequences to make this work, and I only have a few thousand.
Right. Would you like to do some data labeling for me?
No.
Danny has been responsible for labeling almost every dataset I have ever trained on, and yet the next 24 hours nearly broke him. Danny has been working on the labeling for like 3 days at this point. He's got over 90,000 frames labeled. He's not talking to anyone, he's just silent. Hey man, how's it going?
Yeah, great. Really, thank you for giving me this task.
That's all right. Are you nearly at the end?
No. You know how many frames there are.
Eventually we had a brand new data set. I was certain that this time things would work. I decided to tweak the model too. Longer context length. More samples per second. We trained for longer and things were looking pretty exciting. There was just one problem. Okay, that didn't work either. The problem is, Valorant has so much variance. Every single map can look completely different if all the characters are using their abilities at the same time. Like, imagine a huge sage wall is put down, so you can't really use depth mapping. Or imagine like a Phoenix molly. You put down fire everywhere and suddenly the ground looks completely different. So if the model's learned to predict like this color of grass means I'm in A main, and then you put down a Phoenix molly, the model just doesn't, it's just not smart enough to know that you're still in A main. And I thought that the sequence transformer would fix this, but it doesn't seem to be working. I think we can fix it with like a ton more data, maybe like 100 times more data, but I'm pretty sure we can't ask Danny to label 100 times more data. So one idea I have is to auto-label the data this time. Basically just have a system, watch the screen, look at the minimap, highlight where you are on the minimap with just like a normal object detection model, just like literally find the icon of where you are on the minimap, and then overlay the grid on the minimap and just use the overlap of where you are on the minimap to highlight the cell of the grid that you are. And we can do that for every single frame. We can label like 100 times the amount of frames. You know, actually, if we can do that, that's just the production system right there. That's the problem solved. If we can tell where you are on the map from the minimap reliably, we don't need to do any of this. We can literally just find out where you are from the map, from the minimap, like a normal player. So I realize now that I can just use the labeling system in production. So I'm probably just gonna do that. Back to the office, I guess. So at this point in the project, I realized that everyone has different map preferences. They have different scales, different zooms. Some people like the map to orbit. Some people like the map to stay still. Some people want it super zoomed in, and some people want to see the entire map at the same time. And that basically means that this method isn't going to work without a bunch of new features, a bunch of new transforms and orbit controls, and I'm also going to have to remember the last time I saw people so that I can kind of like predict where all of the teammates are on the map as well, even if they're not currently in the minimap crop. So I guess I'll go and do that now.
God, it's actually working. Look at this.
Do you know it's work?
Yeah, it's working. Check it out.
Oh, damn. Mate, I did not think that was going to actually happen. Nice.
Finally, the system was actually working. We could identify who your teammates were, where they were on the map, and even adjust for crop and rotation. So you can have your minimap exactly how you like it, and the system will just handle it. Okay, if you like this video, please hit the subscribe button. It would mean the world to me. Next week, we're going to be building something extra for Debrief, so stick around for that. See ya.